Hello everyone, how are you doing? I trust you are all doing great. James from JTS Maths Tutoring here. I trust 2025 is good to you thus far. Let's start from where we stopped the last year. Today we are continuing with the matrix equations. So we wanted to solve for A in this matrix equation. So for us to be able to do that, we are going to take inverse on both sides. We all know that when you take the inverse of an inverse, you arrive at the original matrix. So this is exactly what is happening here. So when you take the inverse of this left-hand side expression, you'll be left with what is inside the brackets, which is what we have right here. Then we come and take the inverse of this right-hand side matrix. We all know how to do this, right? First, we get the determinant, and then we swap the position of this -1 and the 5, and we negate this 2 and this 4. All right, beautiful. So -1 multiplied by 5, that's going to give us a -5, minus 4 multiplied by 2, that's going to be an 8. So -5 minus 8, that's going to give us -13. So we know that this is going to be 1 over the determinant, which is exactly what we have right here. The next thing, what we have to do is to distribute this -1 over 13 and subtract the identity matrix on both sides. So this I, with this subscript 2, it's simply telling us that this is a 2 by 2 identity matrix. So we have seen we have done exactly that, and we are left with a 2a here. But remember, we are actually solving for a. So the next thing that we are actually going to do is to divide both sides by 2. Boom, there we are. We've actually solved for a in that matrix equation. All right, let's go to question number 2. Question number 2, we do exactly what we just did in the previous question. We take the inverse on both sides. By so doing, we are left with what is inside the bracket here. So I know you know the drill right here. You multiply every entry by 1/2 and you add the identity matrix to both sides. The next thing, you divide by 3. All right, now you are left with the A transpose here. So how do we arrive at the original matrix here? Take the transpose on both sides. The same way you take the inverse of an inverse and arrive at the original matrix, when you also take the transpose of a transpose, you arrive at the original matrix. Beautiful. There we are. That's going to be our A. All right, let's move on. Okay, wonderful. This may look, oh my God, what the heavens on earth? And how am I going to do this? So I just want you to see what I've done here. First and foremost, I just wanted to prove if this can actually be solved. So what I actually did is that, okay, let this 3 by 3 matrix on this left-hand side, this one here, let it be B. And the 2 by 3 matrix on the left-hand, on the right-hand side, let it be C. So what this means that AB transpose is going to be equal to C. If you take the transpose on both sides here, this is what you're going to get right here, right? You multiply both sides by the inverse of B, assuming that B is invertible, all right? And this is what we get right here. But I want you to see something here. The transpose of this matrix here is going to be a 3 by 2. And the inverse of B, it's actually going to be a 3 by 3 matrix. And now we can see when we look at matrix multiplication, it is only defined when the number of columns in the first factor is equal to the number of rows in the second factor. Now you can see here we have 2 columns here and we've got 3 rows. This means that this is undefined. Thus, A cannot be determined. Beautiful. You move on. All right. Let's look at question 4. Question 4, you see, it's very similar to what we just did just now. But first things first, obviously, you need to take care of what is inside the brackets first here, right? Okay. And then now, for this to be defined, it means the A transpose is supposed to be a 3 by 2 matrix, right? So let that be this. And obviously, this which you are seeing right here, where I'm circling here with my cursor, it's the simplification of what is inside the bracket here. So check it out. Look at what I've done here. And here I've actually proved that this, for it to be defined, this is exactly what it's supposed to be like. Okay, cool. Then you solve for your matrix equation here. Beautiful. This is what you get is your A transpose. But remember, we are solving for A. So we take the transpose of this transpose. So this is what our A is going to be. Okay, so what we could have done right here, we could also have solved this equation by solving this equation here. So we assume that after everything has been said and done, what is inside the brackets, it's actually B multiplied by that is going to be. So when you get that, you notice that it was actually going to be defined, but I did not decide to go that route because it is actually going to be time consuming. There we are. That's what we have for you for today. Till we meet again, do not do what mama wouldn't do. See you soon.